Welcome to GIS540. Today we're going to talk about pseudocode. For a warm-up exercise, I've got everybody in the class looking at this example, which has about a dozen lines of pseudocode. And they're trying to describe it very briefly, not quite a tweet, but in less than 200 characters, just a quick description of what's going on here. Encourage the use of abbreviation and also to look at what's going on in both. The hint down here says what's going on in both of the cases. So what are the two cases, first of all, that we're talking about here? When I say cases, what do I mean? Yeah, situations. Like what specifically are they in this example? Yeah, you've got two different prefixes that you're looking for. Your task was to try to write a real short sentence that would describe this whole situation. Does anybody feel like they came up with, that they could say in a nutshell what they have? Okay. That is quite good, actually. If you actually wanted to check if your solution was within the constraints, what would you do? How could you use Python to do that? Yeah. How do you find string length? Yeah, so you would say len, parentheses, quote, it's looking at the folder names and all that stuff that you said. In a nutshell, it's looping through each of the folders and checking a condition, right? Whether it starts with this or that, and setting the bands, a mask. Now, one thing that I wanted you to notice was something identical is happening in both of these indented branches. What's that? Yeah, and is it adding to the same list? Yeah, it's adding to the same list. So actually, it's not an efficient way to write this pseudocode, and not as clear because you don't see, okay, no matter what happens inside of here, we're appending it to the same list. So this statement should get crossed out inside of here and put down here. Something like the answer that appears down here. Pseudocode is language agnostic. In other words, anybody who hasn't had any programming should be able to read it and get some idea of what's going on. That was kind of the main take-home messages of this, is that this is pseudocode and it's meant to be interpretable in a way that doesn't require that you know the specific syntax of any particular language. Do you use curly braces? Do you use colons? You know, what is exactly going on? And the words that are in all capitals are pseudocode keywords. Just like Python has keywords, pseudocode has its own set of keywords. And in pseudocode, usually the convention is to put those keywords in all caps so that you can quickly look through the code and see, oh, here's some kind of condition going on, if or else if. And those really jump out at you. And in pseudocode, we also don't have those conventions, or we don't have the syntax to use. So we usually have to explicitly state when an if block is ending or when a for block is ending. Notice this structure up here for each folder in the Landsat folders. That's what we call a loop, a repeating process. You either use the keyword for or the keyword while for those. You'll see the keywords if, else, else if together, and end if together for decisions you need to make. This is telling you that the thing that's being repeated is ending right here, ending that for loop. If there were lines of code below this, you would know that they're not being repeated for every folder there is. Everybody in here is familiar with Model Builder. You can think in terms of Model Builder as being a visualization of pseudocode. It's got things that are inputs. So in this example, we've written this model in terms of pseudocode down here. So we're setting all of these inputs, setting the output variable name, and then calling the weighted overlay tool. So that call is a keyword as well. And then we're setting the input for the reclassify tool and setting the output for the reclassify tool and calling the tool itself. Those are a series of linear steps in the model. You look left to right. In the pseudocode, it goes top to bottom. In code in general, you're telling the computer exactly what to do. Now, this is where some teachers would have some peanut butter and jelly here. Has anybody ever seen a demo with making a sandwich? Well, I didn't bring the sandwich, but it's a great way to explain that the computer needs a set of instructions that are step by step by step. Let's pretend I have some bread and some peanut butter and some jelly. How would I go about making a sandwich if I'm a computer and I only understand individual steps? Would you like to tell me how to make my sandwich? Okay, put bread on table. Well, it's in a bag, so I don't know. Yeah, so yeah, I mean, it's so you know, steps and steps. So you open bag. Oh, 2 slices of bread. Take out 2 slices? How about take out 1 slice, take out another slice, right? 1 step at a time, 1 step at a time. I have my bread now. Would anybody like to help us along? Import peanut butter. That's good. Right? So somebody would have to tell me I need to open the peanut butter, and then I wouldn't know what to do because I'm a dumb computer. Right, I need something to spread it with. And then I'd have to be told to pick it up and dip it in there and spread it around. And then what? You never get enough the first time. So pick it up, put some more on, spread it around. Repeat until the piece of bread is full with enough peanut butter on it. And so forth. You have to repeat the same things for the jelly till you get your result. Those steps in the model builder model on the previous slide were sequential steps, just like Google Maps tells you. You go here, you turn left here, you go a mile, you turn right there. And those are one step after another. Selection, like in our first example today, that's the selection between if the folder name starts with LC8, do such and such, else if the folder name starts with LT5, do other thing. That's a selection. Right there you're branching and you're doing one thing or you're doing another thing. So the selection is sometimes called decision making or branching as well, because if you were to draw a diagram of it, kind of like this model builder model, you go one way or another. It branches off depending on what your decision is. And then with repetition, we had repetition in our tweeting example, which repeated what? Yeah, so you had your list, and you went through every folder. You had a set of folders, and you repeated your branching sequence. Whatever was inside of there, you repeated over and over. How many of you know how to make lasagna? It's a nice example for repetition because you go through layers, and you do them over and over until you run out of whatever ingredients you have. So you put the tomato sauce down, and then you put a layer of cheese sauce, and then you put a layer of noodles, and then you again put a layer of tomato sauce, and then of cheese sauce, and then of the noodles, and you go on and maybe 3 or 4 times until you've used all of your sauces, and you have your little broken bits of lasagna that you're trying to put on top. That's repetition because you're doing steps. In each of those layers, you're doing tomato and a cheese and a pasta. You're doing those steps over and over and over again. Just like our Landsat folders, whatever's inside of that loop, call it looping. We do it over and over again because we're just turning back on ourselves and doing those steps over and over. This slide shows pseudocode keywords, not to be confused with Python keywords, that are used in pseudocode commonly. Depending on who you ask, you're going to see a different list, but this will be the set of words that we use in this class. We could go through lots of examples of sequential things. If you read a description of a project, it should be able to be boiled down into a set of pseudocode. This is a description from the beginning of class. I asked people to say what do they want to do for their final project. So this was somebody's blurb about that. And so, okay, we could make it into pseudocode there. What about the one at the bottom? Can you write pseudocode to explain that? On a monthly basis, I download the tax data from the tax department database, convert it to a table readable in ArcGIS, and join it to the parcel data layer via a SQL join. maybe you'd start by saying call download tax from tax department database. Pseudocode is very open-ended. You're kind of making it up as you go because you want to make it understandable, readable to anybody who doesn't necessarily know code, your advisor, your committee. You might be describing a process that you're doing for your thesis, and you don't want to get into syntax when you're describing that because you're going to get questions. But then you might say call the convert to DBase table process. You may have had something different written down. Call join to DBase to parcel data. Those are just some sequential steps. Now, if we were going to describe doing this for a year, you might say for each month of the year, and then you'd have these things inside, and then you would end for at the end of that. What about this example? So I want to add a new field to the table for zip codes, but sometimes that field may already be there. Get the table name, get the field name. If the field exists, then do nothing, else call add field end if. Is there a way that I could make the pseudocode better, more succinct, less lines? Yes? Yeah, I really discourage having a block that says do nothing. Usually it means that you could write it more succinctly by flipping the case. So instead of saying if the field exists, if the field doesn't exist, then call add field. And then you wouldn't have to have an else condition at all. The else is that you move on. The implied do nothing. So check if a tree has been recorded in the database. If it hasn't at this point. So we'd start off, say, get database name, get tree record, then what? Write it down? It should have an if, and probably you're going to say if the tree record is not in the database, then add the tree record to the database. In pseudocode, you put a then at the end of the if statement. Then you end it. So 3 lines. Add the tree record to the database and then end if. So if it's not in there, then add it, end if. This slide repeats what we were talking about on the previous slide, that the do nothing is unnecessary. But I just want to point out the pseudocode keywords, set, call, if, then, else, end if. Those are all caps, and that's intentional. And we also do use indentation in pseudocode to make it easier to read. In things like conditional statements where something's going on inside of there, we use indentation to show that it's part of what's going to happen if that condition is true. What we're just trying to do is warm up for all the syntax that's going to come afterwards. We're going to talk about how to write conditional and repetition and procedures in Python code, in Python syntax. So like later in the class, we'll be talking about how to write a function with Python, how to write your own function. But in pseudocode, you sometimes also need to express that there's a block of related steps that you want to name a function, and that you would just want to call that within your pseudocode. Your pseudocode for function would start with all caps func, so func and then the name of the function, and then anything that needs to be passed into. So this one is saying if the highway number is even, then orientation is east-west, else orientation is north-south, and then we return. So it's asking, when we call the function, we want to get back what is the orientation. So this last line here says end find orientation because it's ending the function, and that's the name of the function. So that's one style, one way to do it. So down here we're actually calling the find orientation function. And so in this case we're passing in the number 50 and printing the orientation. So if we pretend this were code, we would go in here and what would it print down here? East-west. Yeah, east-west. That's right. So repetition can either be expressed with a while keyword or the for keyword. While is usually used if you don't know how long it's going to be before it ends. You don't know exactly how many times it's going to repeat. The for loop is for when you know how many times it's going to repeat. So reproject each shapefile in a list to NAD83. So you could get the list of shapefiles and set the coordinate system to NAD83. And then for each file in the list, you want to reproject. We want to set the output file projection file name and call the project tool. And that's all we're doing inside of there, so we can then say end for. So that was an example using the for keyword, and then we also have this while keyword. The while keyword can be used with numbers in this way. So for this example, we're modeling gypsy moth spread scenarios. We want to buffer for the next 100 years every 5 years. Modeling these different spreads, we want to use different time scales. We're using this model for the gypsy moths that gives us a buffer distance. We go up here, we set the first year to 2010. Say the study started in 2010. And we set the spread rate. And then we use the while keyword. So while year is less than 2111, calculate the buffer distance based on the year and the spread rate. So we have some model used to calculate that distance of spread. And why do we want to set the output buffer name inside of this while loop? Why wouldn't we want to set it up here where we're setting everything else? Yeah, we want to have a different output. We want to have a bunch of different output files, right? So if we set the output file name up above before we start doing the repetition, we're only going to have the same output name every time. So that needs to happen inside of the repeated steps. Call the buffer tool on the input shapefile. We need to have something else here before we end the while. At the beginning of this loop, we're testing the current year. Here we've set the current year to 2010. Here we say while the year is less than 2111, calculate the buffer. And then we end the loop. And then we go up and we say while the year is less than 2111, and then we buffer again, and we go round and round. There's a step missing down here that needs to happen so that what changes? So that it happens every 5 years. Now we're stuck on 2010 because there's no statement inside of here indicating that we're updating the year. We need to fix that, right? So we need to increment that year. Otherwise, stuck forever. In the examples that I've shown, we had repetition and selection and isolation, but those can be used together. Well, in the example that we started with, the tweet this example, we had repetition and selection inside of the repetition. So a selection was being repeated over and over. And the way that you do that, notice, is that you indent. So you indent inside of a for loop or a while loop, and then you indent again inside of a conditional block, right? So that shows you that you're doing those things that are indented, as well as having this end if to kind of bracket it at the end, and the end for to bracket at the end. So it's a reinforcement of where are the things that are inside of the repetition or the branching. So you keep indenting more layers as you need to based on the level you're in. For this example down here, we're converting ASCII files in a directory to raster format, and the directory contains non-ASCII format files too. So can you think how you would use a for loop to loop through those, and then use a conditional statement inside of there to check? Can you write that down? To check if it's ASCII files before you do the conversion? So So you have a list of files in the directory, and then you want to loop over, you want to repeat the same process for every file. But inside there, you need to make a decision. So this should, your for loop should line up with your get. And then you start indenting, because now you're doing stuff inside of a repetition. And then you need to make a decision, so you're branching. So you do that, and then you're deciding, well, is the file in an ASCII format or not? If it is, then you set the output raster name, call the convert to ASCII to raster, and you end your if, because that's all you're doing inside of there, and you're ending your for. You may or may not have had to set the output raster name, and that's, yes?
Why don't you have to do it also? What if it's not?
If it's not, we're just, what? Yeah. We don't have to tell it to skip it. This is the beauty of conditions. If it's true, you're doing it. And so the if not is kind of implied that you're doing. Framing the loop. Okay. So one thing that came out in the tweet this example was that there were some things inside of the block that didn't belong inside the block. With loops, it's also, there can be things that need to be in the loop and things that really shouldn't be in the loop. So you have to think about what does need to be repeated and what doesn't. So I have a large number of tables in my MS Access database, Microsoft Access database, MDB. I want to convert each table to an XY layer, then save as shapefiles in another folder. Then I want to merge all the shapefiles into one shapefile. So first of all, you have to get the looping objects so that you can state what you're looping on, and then determine what goes inside the loop. What is repeated? So for this one, we can say get a list of tables in the MDB, call create output folder. Okay, that's something that you may or may not have thought about doing, but that's a step that would have to be done. So there's always a wiggle room on level of detail for pseudocode. But anyway, so for the for loop, you're going to do something for each table in the list of tables, which is call make XY layer, call save as shapefile in an output folder, and then call merge shapefiles according to this pseudocode. Call merge shapefiles in the output folder. So there is a mistake. Actually, there's more than one mistake in this pseudocode. Can you find it? The indent. Yeah, you would want to have that back here, if that's inside the for loop step. And what else is wrong with it? So I warmed up this slide saying, framing the loop. What things need to be inside and outside of the loop? Very well said, Paul. Merging should be outside. Why? You want to merge all of the shapefiles into one shapefile, right? This would actually eventually give you the right thing, but you're doing merging over and over again for no reason. What you want to do is merge on the final list of shapefiles that you've got. So you don't want to merge inside the folder, because it's inside the loop. So what this would do is, okay, first time you go through it, you would make XY layer from the first table and save it as a shapefile. So you'd have a shapefile, and you would merge the shapefile with itself. I don't even know if it might throw an error if you try to do that. I'm not sure. Maybe it allows you to do that. Anyway, then you would go again, and you would get the second table, you would make it into a shapefile, and you would merge the first table, or the first shapefile, and the second shapefile. Then you would go again, make a third shapefile, merge the first shapefile, second shapefile, the third shapefile, and so forth, right? Which there's completely a lot of unnecessary merging going on over there. So you would need to move that call to out here. So call merge shapefiles in output folder, and that would be a much better solution to the problem. So think about in terms of what needs to be repeated and what doesn't, both for logic and clarity of your code, but also for efficiency. It's going to take a lot longer to merge, one and one, 1 and 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. Yeah, instead of just merging 1 through 10 all at one call at the end. For this example, write down some pseudocode for it. I have weekly dumping data of dredged materials in DBF files for 1 year and want to make a raster for each week and a combined raster for the entire year. These steps need to be taken. Make XY event layer from DBF file, clip with disposal site S1, convert the file to a raster, and sum all of the rasters in the folder with a weighted sum with a weight of 1 for each. Can you write it down? How would you set this up? It's obviously going to be a repetition, right? What are you repeating over? What is there multiple of that you're doing stuff to? What's that? Yeah, DBF files, database files. There's multiple database files, and you're starting out by making an XY event layer from each of them, right? And then you do something to that event layer. You clip it, and then you convert it to a raster. The clipped output to a raster. So you'd set it up, right? You'd set it up by setting your list of DBF files. And then probably using the keyword for each. Do you know how many there are ahead of time? It's not a while loop situation. What's that?
Am I missing anything?
The only thing I would say when I'm grading your exam is I can't tell the difference between your uppercase and your lowercase. Or maybe I can. You have to, in this case, you have to have this outside of the loop, right? That one shouldn't be inside because it's happening for all of the output that you create. You're creating these outputs as you go through the loop. It's the same as the previous example.
Repetition can also be nested. Suppose your goal is to model various gypsy moth spread scenarios using 5 different spread models to generate multiple buffers representing spread over 10 years from 2010 to 2020. This pseudocode uses nested looping because we have a repetition of years and a repetition of models, and we need to do each model for each of the years. First we get the input shapefile, then for each projection year we do a loop inside, a repetition for each of the 5 models. We calculate the buffer based on the year and spread model. Then we calculate the set an output name for the buffer so that we'll have unique name based on both the year and the spread model, and call the buffer. This occurs for the first model, for the second model, and so forth for 5 models for the first year. Then we move on to the second year, and the 5 models are used again. This means that in the end we'll have 10 years times 5 models, or 50 output buffer files. Notice that the indentation only starts when we have nested looping. We don't need to put we don't necessarily need to put a repetition indented, but what's inside of it needs to be indented. Only the first inner layer is when we start indenting. And then we indent again inside of here because this is a block of code that is happening within the inner loop. So here we have the pseudocode again. If we were to take this workflow and rewrite it as a while structure, how would that look? We know that we have to get the input shapefile, and for a while structure we have to have a starting point so that we can test when to stop. That means we should first of all set the year. We want it to run from 2010 to 2020. And then we can test our condition. Is it time to stop? That's what we do at the beginning of a while loop. And usually the first time we get to that condition, it's not time to stop yet because we want to go inside there. So our condition can be while the year is less than 2021. That means it'll go in there when the year is 2020, but not when the year is 2021. Now, we've substituted the while loop for the for loop. The inner for loop was not being replaced. We were just going to substitute the year for loop with the while loop. So everything that appears inside the inner loop should again appear here. Now we'll need one more thing before we can end the while, because we are using a while loop, which is to update the looping variable, the while looping variable, which is the year. That's what's updating, what we need to update every time we go through the while loop. So the year, we need to increment that. And then we can end the while loop. It's set year to year plus 1, or year equals year plus 1. Be another way to write that. So notice there are 3 levels of indentation, just like there were 3 levels of indentation here. It's just a different variation. For more practice on nested looping, take a look at this description written by one of our former students who worked for the City of Raleigh. I work with a data set for the City of Raleigh that contains all of the trees that have been inventoried in the city's right-of-way, and some of the data has not been properly checked back into the system. From time to time we manually update and add those missing points. The raw data is recorded in a set of spreadsheets. I want to automate going through the spreadsheet files, comparing each record to the database, and then add missing points to the database. When you're planning out a big project, it's a good idea to write down the workflow before you try to write Python code. So that's what we're getting at with this lesson. Just planning out a workflow in a very abstract way without having to worry about the implementation details. And we know that we have these structures, the basic steps, 1, 2, 3, sequential steps, the selection, if, then, else, if, else, and the repetition, for looping, while looping. So for this problem, we have a set of spreadsheets, and each spreadsheet has a set of records inside of it. So that means that we're going to need to do nested looping because we've got multiple records inside of each of multiple spreadsheets. So we probably want to start with getting this data and then looping through the set of spreadsheets. That's got to be on the outside because you don't want to open each spreadsheet and look at the first tree and then open every single spreadsheet again and look at the second tree. Right? Even by hand you wouldn't want to do it that way. So in the pseudocode, the spreadsheets should go on the outside. And that's how it should always be, if you're looping through a set of files and looping through each of their records inside of there. So for each spreadsheet in the list of spreadsheets, we're going to then do the nested looping. We're going to go through for each record in the current spreadsheet. If the tree record is not in the database, then add tree record to the database. So we're doing some kind of a query there for the if statement, the database. We have the record in the Excel spreadsheet or whatever it is, it's some CSV, and we have that record information, we query the database for it. If it's not in the database, we add the record to the database. If it's already in there, we don't want to do anything, so we're going to end the if right here. Then we can end our for loop, our inner for loop, and end our outer for loop. So this time we have 1, 2, 3 different levels of indentation. Two of them are, well, 3 of them, because we have the inner for loop and the inner conditional, and whatever's inside of those needs to be bumped in. We keep the outer one at the main code level because there's nothing outside of that making it an indented block. This lesson discussed workflow visualization with Model Builder, mainly so that we could take that and convert it into pseudocode. The 3 main structural components, which were sequence, selection, and repetition. Pseudocode keywords that are commonly used, for example, for, while, if, else, then, func, end funct, all the ends, call for functions as well, return for functions as well. And we spent time looking at examples of sequences, selection, functions, repetition, and then combining parts of those together. We took a bunch of examples from prose to pseudocode and got some practice converting a for loop to a while loop. And we saw several nested looping and selection combinations as examples. That concludes this session. The next session will discuss decision making.